And here's what we were kind of hoping to work on last time. And that's that we're going to take a quadratic in the form of ax squared plus bx plus c. One really important thing that we need to think about is when I say the a value is the value in front of the x squared. It's the coefficient, okay, the number in front of the x squared. The b value is the number in front of just the x. And remember that the variable might change, right? It could be x's, it could be y's, it could be u's, m's, it could be anything. Okay, and then the c value is the constant term or whatever, it's just a number. Okay, it won't have any variables attached to it. So after we have these three terms, we know that we're using this box to help us go from this quadratic in standard form to its factored form. Okay, and to get it into its factored form, we've got to do a couple things. One problem we have is that when we're given a quadratic, typically there's only three terms. For us to use this box, we need four terms. So the first thing is we need to find a way to split up the bx. We're going to do that by finding two numbers that multiply to the outer two numbers, or the a times c. So two numbers that multiply to a times c. Those same two numbers also need to add to b, or the middle number. That's something that's going to be pretty tricky for a lot of you. Okay, how can we find those numbers? You want the focus to be more on the numbers that multiply to a times c rather than the values that add to b. Now, a couple things that will happen from here. We will always take the ax squared and put it in the top left. We'll always put the c, or the constant term, in the bottom right. And then the other two boxes get filled in based on what these other two numbers are. So we've got number 1 and number 2. And what those numbers are doing is they're taking this bx and they're turning it in to whatever those two numbers are. So plus number 1 and it gets an x, plus number 2 and it gets an x, and then plus c. So now that I have four terms, these last two boxes are filled in with whatever these numbers ended up being. So number 1x and number 2x. Once we have the insides, I'm going to talk today about a couple strategies for how we can figure out what the outsides are. So the outsides are what we're ultimately trying to find. Those are the factors. And remember, we've used the boxes to multiply factors to get an equation in, or quadratic in standard form. Okay, so we've used these boxes in the opposite way. Now we're just reversing the process. All right, so the outsides, again, will kind of be dependent on whatever it is that we start with. But this is the main thing we need to be able to do. Can we fill in the box so that we have four terms, and then we'll work on strategies to find out what the outsides are shortly after. Any questions just about anything A, B, or C value? Okay, or finding those numbers or filling in the boxes here. Okay, so let's go through a couple examples together. And know that all the steps we're going to take are right up here. Okay, so we can kind of come back to this. It's basically what I just explained. I just set this up a little bit differently in terms of how I'm finding these values right here. Okay, but when in doubt, you can kind of come back to this, and this is what we're going to work through right now. So the first thing, again, we do not have four terms. We need a fourth term, and we find that fourth term by looking for numbers that multiply to a times c. In this case, a is 2, b is 3, and c is -9. So if I take a times c, that's 2 times -9, which is -18. Those same two numbers also need to add to the middle number of 3. So I'm looking for two numbers that multiply to -18 and add to 3. Some of you are going to be really good at finding these numbers. Others of us, might be the hardest part about this. I will always suggest that you think about numbers that multiply to 18. And of those numbers, which of those can we get to add to 3? So I'm going to make what I call a factor tree of 18. And I'm going to list out all the numbers that multiply to 18. So 1 and 18, 2 and 9, 3 and 6. And I'm thinking about which of these numbers can I get to add to 3? Well, definitely not 1 and 18. 2 and 9, I can get them to add like 7 or 11, okay, but never 3. But 3 and 6, I can get to them to add the 3 if I make the 3 negative. Okay, so our numbers are -3 and +6. What's nice about this whole process is there are checks built in everywhere. If your numbers that you write down don't meet these conditions, including the signs, you don't have the right numbers there. Okay, they need to multiply to that -18 and add to that +3. So these two numbers are taking the 3b and it is splitting it up to be -3b plus 6b and then -9. Now I have my 4 terms to fill in all the boxes or all the insides of the boxes. So I've got 2b squared in the top left. The squared term always goes in the top left. I got the constant term in the bottom right. That will always go in the bottom right. And then where you place the other two does not matter at all. Okay, you could put the -3b in the top right or bottom left. It makes no difference whatsoever. So -3b and 6b. All right, so last time when we worked to find the outsides, we were thinking about greatest common factors in each column and each row. That still works, but I think a lot of us that's where I lost you, and we maybe weren't able to kind of figure it out. So another way to approach how we find the outsides is let's just think about multiplication. And what terms can we multiply to get this 2b squared? We always want to start with that. Well, there's only one way to get 2b squared, right? That's to multiply a 2b times a 1b. There's no other way to get those. So I'm like, okay, I either have a 2b up top or on the side. I want to put it in a place where I can take that 2b and multiply it to either get 6b or -3b. So the 2b has to go on the top here, or wherever that 6b ends up, wherever I place that, I need to put the 2b so I can multiply something to get to that 6. Okay, so for me, that ended up being up top here. That makes this term on the side a +1b. And now this b times 2b gives me 2b squared. The reason I like this is because now I'm only concerned with multiplication. I'm thinking about b times what is -3b. That'd be -3, right? -3 times b is -3b. Same thing with this bottom term. 2b times what is 6b? That would be +3. And then our check is 3 times -3, -9. Yeah. Okay. And again, your check is all built into this. 2b times b is 2b squared. 2b times 3 is 6b. b times -3 is -3b. And 3 times -3 is -9. So we should always, like a lot of students last period were like, Miss Youngren, are these right? Like, well, you should be able to check that. It's built in to how we set this all up. So this factors to be 2b minus 3 times b plus 3. All right. Any questions there? All right, let's do another one. And then the next two we're going to do with our groups. All right, so again, our first problem is that we only have 3 terms. We need 4. So I'm going to find how I'm going to get to that 4th term by thinking about 2 numbers that multiply. The a times c, or 7 times 6, which is 42. So in this case, I should always say that a is 7, b is -43, and c is 6. So they have to multiply to 42. They have to add to negative 43. A lot, again, if you're having trouble finding those numbers, another way to find them is you can grab a calculator and just start dividing by guesses. If that's the approach you're going to take, I would always start with 1. So I'm like, okay, 42 divided by 1. Well, that's just 42. Yeah, I knew that. Well, can I get 1 and 42 to add to 43? Yeah, right? Those are my numbers right there. I just need to make them both negative. So these two numbers are negative 1 and negative 42. Now they add to negative 43 and still multiply to a positive 42, right? That's one place to kind of check. If those numbers don't meet those conditions, you don't have the right numbers in. So this quadratic is actually 7x squared minus 42x minus 1x plus 6. Now we have 4 terms, a place for each term to go in each box here. So 7x squared minus 42x minus x plus 6. All right, and again, how I can think about the outsides, I can think of the greatest common factor in each column and each row, or we can just use multiplication and think about what times what will give me 7x squared. Well, once again, there's only one way to do that, right, with 7x and x. So I'm thinking about where do I need to place the 7x so I can get it to multiply one of my other terms. I need to place it so that I can take 7x and multiply it to get negative 42x. So for me, that's on the side. That makes this other term x. And now I'm just thinking times what is negative 42x? That would be negative 6. X times what is negative 1x? That would be negative 1. And negative 1 times negative 6 is positive 6. So our factors are 7x minus 1 and x minus 6. All right. So here's how we're going to work through the next two. We're going to kind of do it in chunks. Let's first start by seeing if we can't just set up the insides of our boxes. Okay, so can we find the two numbers that multiply to a times c and the numbers that add to b to be able to help us find all the insides of the boxes? We'll check and make sure we all have that part right, and then we'll think about how we can find the outsides. So for now, let's see if we can't just worry about the numbers that add to b and multiply to a times c. Give you like 4 minutes to do that for each. Again, I just need you to try right now. Just kind of piece these together. So for 3 and 4, I'm starting by finding two numbers that multiply to a times c. A is 5, b is 29, and c is 20. So a times c is 100. B is negative 29. So those numbers here are negative 25 and negative 4. Now again, if you're having a hard time with those numbers, in the calculator, start with what we need them to multiply to, so 100, and just start with guesses. Now the best way to go through these guesses, just start with 1 and then go 2, 3, 4, 5, etc., until we can find numbers that add to 29. So I'm like, okay, 100 divided by 1. Well, 1 and 100, no way I can get those to add to 29. So definitely not that. So I'm like, okay, what about 102? We're 100 divided by 2. 2 and 50, we're still quite a ways away from 29. So not that. So what about 100 divided by 3? Well, that's not even a whole number, so 3 is not a possibility. And then when I get to 4, I'm like, oh, wait, 4 and 25 I can get to add to 29. And negative 29 by making them both negative. Okay, so for some of you, you might have to do that every time. It all depends on where your number sense is. Okay, how are you with your multiplication? Some of us are pretty good at it, some of us not so much, and that's okay. Okay, it's absolutely okay. So again, those numbers, they're splitting up the negative 29K into negative 25K and negative 4K. Now I can fill out all the insides of the boxes. And here in a second, we're going to work on finding the outsides. Number 4, A times C. A is 3, B is 7, C is negative 10. My two numbers, negative 10 and 3, are negative 30. And they need to add to 7. Those numbers are 10 and negative 3, multiplying to negative 30, and adding to a positive 7. And now I can fill out all the insides. So now, if you haven't done so already, take like 2 minutes to think about what the outsides need to be and thus the factors. Again, I think a better way from how we explained it last time is to focus more on how do you get the top left term first. How can I get 5K squared? And how can I get 3R squared? And let that drive how you find the rest of the other terms. Okay? Yeah, Brandon, go ahead. Yeah, okay. So again, remember that these numbers, and we have that written down up here as well as on the back, they multiply to A times C and add to B, right? And the signs, if for them to multiply to negative 30, one number has to be negative, right? I'm choosing the 3 to be negative because they're adding to a positive 7 because that's what the B term is. Okay, so it's negative 3 plus 10 to get to that positive 7 there. Okay? All right, take 1 minute. See if you can't find the outsides and thus the factors. And we've got a couple more to do on the back. Yeah, it's like that whole region. To get 5K squared, there's only one way to do that. With a 5K and a K. 5K times K gets me the 5K squared. I put the 5K so it multiplies to get negative 25K. Okay, that allows me to take 5K times negative 5 to get negative 25K. Then I have K and negative 4, making that negative 4K. Negative 5 times negative 4 is positive 20. In the bottom one, to get 3R squared, only one way to do that, 3R times R. I'm putting the 3R so that it can multiply to give me the negative 3R. So 3R times negative 1 is negative 3R. Then this has to be R. R times 10 gives me 10R, and 10 times negative 1 is negative 10. All right. Is this feeling a little bit better than what it did on Wednesday? Give me some head nods like up and down, or no, I'm okay if it's still no, that's fine. Give me some feedback here. Feel a little bit better? Half the people aren't even listening to anything I'm saying. Okay, good. I hope everybody feels better. All right. Flip this page over. And we're going to do 2 more, and then you're going to do the last 2 to get your homework. Okay, and you're going to be working in your groups to be able to get that homework. So let's go through 5 and 7 all together. We'll do it from start to finish. You're going to do 6 and 8 in your groups, and that's how you're going to get homework today. All right, starting with 5. Again, the first issue we have is that there are only 3 terms. We need 4. So we need to find 2 numbers that multiply to a times c and add to b. A is the number in front of the v squared. B is the number in front of just the v. C is just the number without any variables. Those 2 numbers that we're looking for multiply to a times c. 12 times 3 is 36. And they add to the middle term of 20. All right, I'm going to say that I can't find these numbers, so I'm going to take 36. I'm going to start dividing it by guesses. I know 1 and 36 aren't going to work, so I'm going to skip that right away. Like, okay, what about 36 and 2? 2 and 18, can I get those to add to 20? Oh, yeah, they already add to 20. So it's 2 and 18. The 2 and the 18. Take the 20v and make this 3v squared plus 2v plus 18v plus 12. Now that I have 4 terms, I can fill out all the insides. So 3v squared, 2v, 18v, and 12. Now we're on to finding the outsides. Let's take a different approach here. Let's think about the greatest common factors, and maybe we can kind of tie that back to what we did on Wednesday. So remember, another way to find the outsides is think about greatest common factor in each row and each column. Squared and 18v, greatest common factor amongst those terms is 3v. 2v and 12, the greatest common factor amongst those terms is just a 2. The 12 does not have a v. Greatest common factor in this first row, 3v squared and 2v, is just v. There's no number that divides 3 and 2 besides 1. Then 18v and 12, greatest common factor there is positive 6. And again, the check is built in here. So let's check and make sure this all works. V times 3v is 3v squared. V times 2 is 2v. 6 times 3v is 18v, and 2 times 6 is 12. So this factors to 3v plus 2 and v plus 6. All right, we're going to do one last one together. And we're going to do number 7. Number 7, the setup or the equation is different than all the others. Why is that? Something's missing there in number 7. What's missing? Somebody help me out here. What's missing in number 7? Sandy is also missing an 8. Giselle, what's missing? Yeah, there's only 2 terms. Okay, so in terms of the A, B, and C, what is it that's missing? Is it the A, the B, or the C? It's the B, right? The value or the term in front of just the variable, not the variable squared. So we're going to fill it in so that there is a B term. So it's 9n squared plus 0n minus 4. Now I have 3 terms. Now it's really clear to me what B is, and that I'm looking for 2 numbers that multiply to a times c. 9 times negative 4 is negative 36. And that also add to 0. Those 2 numbers are 6 and negative 6. Right? The only way numbers are going to add to 0 if it's the same number and positive and negative. So now this is 9n squared plus 6n minus 6n minus 4. And now I have a place for every single term in the box. So 9n squared, 6n, minus 6n, and minus 4. Now I'm going to see if I can find the outsides. This time I'm going to combine the two approaches. So I'm going to actually start with the greatest common factor, but then I'm just going to use multiplication from there to find the other outsides. So I'm going to start with this first column here, and 9n squared and negative 6n. Well, the greatest common factor there would be definitely an n, and then the biggest number that divides 9 and 6 is 3. I guess you could also make an argument for negative 3, but I'm going to leave it as positive. So by that being 3n, that helps me decide that this has to be a 3n to get 9n squared. 3n times 3n is 9n squared. And now I can just do a bunch of multiplication and figure it out from here. 3n times negative 2 is negative 6n. 3n times positive 2 gives me positive 6n. And 2 times negative 2 is negative 4. So this is 3n plus 2 times 3n minus 2. All right, we have, all right, for those of you watching the video, just to kind of check your work with 6 and 8, if you want to maybe pause and work through them, that'd be a good use of this. But with 6, finding two numbers that add to 26 and multiply to negative 27, again, that negative 27 comes from 3 and negative 9. So two numbers that meet these conditions are 27 and negative 1. That allows me to fill all the insides, and thus the factors are 3n minus 1 and m plus 9. If you haven't done so already, work through 8. You might want to pause it before you actually check your work here. In this case, we're missing that middle term of 0v. So I'm looking for two numbers that multiply to a, which is 1 here, times negative 4, which is negative 4, and add to 0. Those numbers are 2 and negative 2, making the factors v plus 2 and v minus 2. All right, hopefully this helps any confusion about factoring. There's a homework assignment that follows. Have a great day.